Hello everyone, welcome to watch this video. In this video, we're going to share with you about our solving question skills for AP Computer Science exams in AB level of Java programming, and we will discuss about question 13 to 17 in this video. First, let's check question 13 and 14. It refers to the following class and declaration. It started with a very simple class. It's a public class called digital clock. It trying to ignores the private instance variables and the constructors. Here we are not interested in that. Instead of that, in this question, we focus on two methods. One is called is defective. It's a public method, return truth. But again, the implementation is not shown. It might be asked instead of following questions. And for this is defective method, it asks the users to check. This method will return true if this digital clock is defective, false otherwise. The second method that has been emphasized here, again, is a public method, but it does not return anything. It's called advanced time. Its function is a very simple mutator method, advances the digital clock by 1 minute. And also there are a lot of other methods not shown because we only want to focus on these two methods. And the declarations below occurs in a client class that we're trying to organize a data structure of the type that we just declared called digital clock. It's an array list, and within the array list are objects of type digital clock, class digital clock, and it's called clocks. The reference of this array list is called clocks. And we just knew this array list of type digital clock with a simple construction. Let's see the second page of our slides. Question 13. Suppose that the array list clocks has been initialized and it contains a non-empty list of digital clock objects. Which of the following code segments will correctly remove all defective clocks? To remove all defective clocks, first we have to use the isDefective method to check. Since we already know that it will try to check whether the clock is defective or not, so we assume that we can just call it without knowing its implementation. This is just a basic concept of object-oriented programming. So later on, we will check a lot of for loop or while loop, and also there will be some if statements which checks the is defective. Now let's see the first implementation and see if there is any problems for this first implementation. Okay, first is the for loop for digital clock C, which is from the array list clocks. If C dot is defective, C dot remove. It seems like very logically that, okay, if this object is defective, then we just remove it. But on the other hand, this C dot remove has not been defined in the previously public class of clocks, digital clock. Instead of that, we will suggest actually to remove something actually should be removed from the array list. So basically, it should be something like clocks that remove instead of that. So the first implementation is incorrect. Let's check the correctness of the second implementation. It started with a very basic for loop with the integer index starting from 0, and it will scan through all the elements bounded by the clock's data size, which means that it tried to use the index to scan through all the digital clock objects in this clocks of array list, and each time it scans through, it increases in index by 1. Okay, so within this for loop, first we have to check. Right now everything's okay. We have to check the index. So in this if, you use if to check clocks that get indexed, which means that we're trying to get that specific digital clock by the index, and a code that is defective to check whether the digital clock inside of this index is defective or not. And if it's defective, it should be removed. Okay, let's see what will happen if we just directly call clocks that remove of index. It seems logically correct, but if you think twice, there is one brief problem. Okay, if so clocks that remove, suppose at the beginning we found that the clock 0 is defective, then we remove it. What will happen is that in the original position, the index 1 will become index 0, index 2 will become index 1. But for this for loop, since in the next execution of the for loop, index becomes 1, which means that we'll skip the second element without checking whether the second element is defective or not. If we found some fault at the beginning of the clock's array list. So the second one is incorrect either. Okay, now we only have the third choice, which means that the third one is correct. But let's still take a look around. This implementation it uses iterator. So it's an iterator which called ITR of type digital clock. And actually it's just directly called array list clocks.iterator. Because iterator is a basic implementations of the array list, which provide a very efficient and simple methods. Why is that? We can see that from here. We only use while ITR that has next, and instead of this while, as long as the iterator currently point has some element, and we use if iterator dot next that is defective, then we use iterator dot remove. This part of remove will still guarantee that after the remove, the iterator that next will become the current position in the next while loop. So there will be no index problem that we found in the second implementation, just because this is a convenience provided by iterator. We don't have to worry about that we calculate the index incorrectly. As long as the iterator can check that, okay, there is a next element, and also we can check that the next element is defective. We just directly remove it. Then the iterator will help us to take care of the rest. Okay, now you know the magic of the iterator, so we know that the correct choice of this question is C. Question 14, again, suppose that clocks is initialized and assume that it contains a non-empty list of correctly functioning digital clock objects. Which of the following code segments will correctly advance the time on every digital clock? Okay, again, let's check these three different implementation. We want to correct the advance time on every digital clock, which means that we have to make sure that if there is a for loop or while loop or iterators, either by using the list of the array list of listing all the elements, or by using the for loop, or by using the scan through the iterators, we have to make sure every objects inside of this array list will be scanned. And after that, reference to that specific object has been referred. As long as we can get it, we just call the advanced time method to finish it. So the first implementation is a very clean implementation. You take advantage of the array list. So it's a for loop for listing all the possible elements of type digital clock, and we call it C instead of this array list clocks. For every such kind of C, we call advanced time. So we won't miss anyone. For the second implementation, this is more careful, and you have to calculate the index by yourself. But again, since it started with index 0 and it stopped with index that clocks that size. Every time it increased once. So within the for loop, we only use the following. We try to use clocks that get indexed to get the exactly reference of the objects of this array list in that specific index. And we, for that specific index, the object in that specific index, we call advanced time. Okay, note right now, since there's no remove, so we are so sure that every element inside of the clocks will be scanned, and the advanced time method will be called. Okay, so the second one is also maybe a little bit longer version, but still correct implementation. Now the third one use iterator. Again, it's the iterator of type digital clock, and with the declaration of them ITR. Oh well, there's no semicolon, but it's just a small errors of the print error actually. So please just ignore it. Now we get the iterator and we use the while loop of the iterator to call has next. And we let iterator that next that directly called advanced time. So as long as there is another next element, then this iterator will directly point out to the next element which has not been processed in the code advanced time function method for itself for that specific element. So the third one is also incorrect, which means that after we see 1, 2, and 3, the best choice is E. 1, 2, and 3 are the segments that correctly advance the time on every digital clock. Okay, let's go to the next page. Is another concept which related to the comparison of a different implementation of a different data structure. Okay, what's the requirement and what will be the proposed solution? Actually, it started with the following story. A large charity organization maintains a database of its donors, and for each donor, the following information is stored. The name of the donor, the address of the donor, is his or her phone number, and also the amount and date of most recent contribution, and the total contribution so far, so that we can control and also we can trace the loyalty or the association between the donor, the healthfulness of a association between the donor and this charity organization. And two plans for organizing and modifying the data are considered. Okay, now we consider two different implementation. The first implementation is by using the data structure, a one-dimensional array of donor objects maintained in alphabetical order by name. So which means that it's an array, and also the elements of this array, simple one-dimensional array, is of type class donor. And specifically, this donor, if you check the index one by one starting from 0, it will be sorted in alphabetic order by its name. That will be very good if you just want to print out the list of donors sequentially by alphabetical order, because it has been stored. Again, it has not been clearly stated how they implement it, but we just assume that, okay, this is how they implement eventually. Okay, let's compare with the second solution. The second solution, they use a hash table of donor objects implemented using an array of a linked list. And the hash address for any given donor object will be determined by a hash method that uniformly distributed the donors throughout the table. So maybe if suppose the hash function is a good hash function, then we probably can say that once we give some specialized key, maybe like the first name, maybe the phone number, maybe address or the amount of date. Amount of date might not be good because it's not unique. Okay, maybe the name or address or phone numbers of the donor. Then we can, in constant time, to check out the content of the index of this array of linked lists. Seems like it introduced a relatively complicated data structure, but aims to save the time for using it. We don't know whether this hash function is correct or not because it depends on whether the hash function is pseudo-random enough or not. So let's see the following 5 questions for the comparison of either a one-dimensional array implementation of reference of object or the array of linked list. Which of the following is false if we want to compare and assume that the most efficient algorithms are possible for both different data structure types? Okay, choice A. Planes 1 and 2 have roughly the same memory efficiency. Okay, notice that is array typed. The first planes 1 is an array. The plane 2 is an array of linked list. So basically, we can roughly say that they have almost the same memory efficiency. That means the scale of the memory space they use, although one might use class, the other might use array, but actually we can assume that the size of each object and also the size of each linked list of an objects roughly are the same. Because I mean, we don't think that linked list will occupy too much memory space. It just besides the original memory space that will be occupied with the donor objects, we only have to restore a little bit of different extra information like the previous and the next, the pointers to the previous elements of the linked list or the next elements of the linked list. So which means that choice 1 is correct. Choice 2, insertion of a new donor is more runtime efficient using plane 2. Why is that? Because we have discussed about the efficiency of the hash method. As long as the hash method is correct and there's no conflict that has been generated by this hash method, then we can be sure that the insertion of the new donor is more runtime efficient by using plane 2. Why is there any obstacles? Is there any obstacles for the first implementation? Because it requires that the donor object will maintain it in an alphabetical order by its name. So which means that at least it might need some binary search for searching the name of the donors with this new donor. So in the worst case, it might take like log n, big O of log n time for the insertion. But if the hash function, hash method that has been used for implementing in this the planes 2, it might only runs in constant time. So the choice 2 is true. Choice C, option C, modifying an existing donor's record is more runtime efficient using plane 2. Why is that? Again, it's because of the hash function. Choice D, printing out a mailing list in alphabetical order is more runtime efficient using plane 1. Yeah, of course, because that's the basic property that has been specified by for the plane 1. Plane 2, although it might access each element correctly, but we still don't know whether how to sort it, how the donor object has been placed instead of linked list. Okay, we have to find the alphabetical orders by additional sorting procedure or other system-based sorting method that has been executed. So D is also correct. Now we only have one choice left. So without reading the content, we know that the choice is E, but let's still take and read the content of it for just in case. Printing out the list of donors in decreasing order of total amount contributed is more runtime efficient using plane 1. Although we know that the plane 1 has alphabetical order, but if we want to use the the name by name of the donors, but there's no clear information about how the plane 1 store the list of the donors by the total amount of contributed. the same also happens for the plane too. So we can, but I mean, it does not matter that the false statement of the choice E, because there's no clear information provided by the. How can we guarantee that how to locate the decreasing order of total amount contributed of this list of donors in both methods? So we cannot compare that because we don't know how they have implemented it. So the fourth choice is E. Okay, the next one is a very simple one. It helps us to realize how to use hierarchical levels of a for loop to access the elements inside of a matrix. So let's consider a class that has this private instance variable, which is called met. It's a two-dimensional integer arrays of type int, and the class has the following method called alter. What is this alter? It has the index c as the input parameter, and instead of that, there are two for loops. The first loop apparently trying to scan everything from the first dimension of this matrix. It starts with the index I equal to 0, row 0, until the last row, where it means I will less than met.length and I++. So it scans through every row of this matrix in the outsider loops, but in the insider loops, what happens where the C works? So it started with the index j starting with C plus 1, and it let j less than met0.length. Yeah, here we assume that it's a matrix, right? So which means that as long as we can bound the first row's length, we can bound the second row's length, and also we can bound the third row's length. So that's why it stopped the index of j by assuming that j blocking j at j less than met0.length, and increased with j++. But you see, what happens that once it's starting to access this index j, it will do is let matij minus 1 equals to matij. That means it will shift the element by trying to copy the second element to the first element's position. The j's elements, the content of the j's elements to the content of a j minus 1's element. So what does that mean? That means if c is equals to 0, and it might starting with a j equals to 1, right? So which means that met I 0 might equals to met I 1, which means that there is some shift of the elements. Okay. And it will stop at the index with next to the last one. So if a 3 by 4 matrix mat is as follows: 1, 3, 5, 7. This is the first row. The second row is 2, 4, 6, 8. Third row is 3, 5, 7, 9. And then alter 1 will change mat to what? Okay. Now, since c, the constant c, has been specified as 1, so which means that it will try to access the column of j minus 1, which is 1 plus 1 minus 1, which is 1. So if the column of that row is 1, it will be replaced by the column of that row with the original element of the position 2. That means if the original 3 by 4 matrix is 1, 3, 5, 7, 2, 4, 6, 8, 3, 5, 7, 9, after calling the alter 1, then it will try to copy the element. by the following. Uh, 5 will replace 3 because 5 is at the position 1, 2, and 1, 1, the original element, it was 3, but it will be replaced by 5. And 5 will replace by 7. Again, if we check the second row, that means the original element 4 will be replaced by its right neighbor 6, and 6 will be replaced by its right neighbor 8. The same thing happens on the third row, where it starts with the index 1. So the original index elements 5 will be replaced by its right neighbor 7, and 7 will be replaced by its right neighbor 9. But since it stops at j less than mat 0 dot length, so the last row will be modified or exchanged. That means the correct answer after we executing this alter method is A. Let's see the last question. Trying to test our knowledge, our professional understanding about priority queue, and also how to implement a priority queue and also queue and also stack. Okay, now let's refer to the following method. It's for deletes a maximum item. That it means the items of the lowest priority from the priority queue PQ. Precondition is that we assume that this priority queue PQ is non-empty. And the post condition is that returns a priority queue that contains the same elements as PQ except for the maximum element which has been removed. Okay, which means that this is a priority queue and we want to remove the maximum element of the priority queue. It's a public method. It will return priority queue of the type. And the method is called delete max with the parameter, again, the old priority queue type called PQ. And now there's a blank of code that needs us to fill in. Is the code to delete the maximum item, and then we return the PRIQ. Now let's check. There are 3 different implementation, and which of the following replace for that implementation of the delete of the maximum item satisfy the post condition for the method? Yeah, first let's check what does this mean. There might be some tricks that could be easily ignored. Okay, although this is a priority queue and we want to delete the maxima item, we might thought it could be max heap or max or min heap. Okay, how to check whether the first statement is true or the second statement is true? It mentioned that the maximum item actually is the item of the lowest priority, which means that the top of the heap for this priority queue, if we use the maxima heap or minima heap for implement, actually, because the maximum item will has the lowest priority, so which means that actually this PQ has been implemented by the min heap. That means we cannot get access for the maximum item just by calling the highest priority element directly. Actually, we have to find the lowest priority element first, then remove it, then do the several implementation. How to manipulate that? Do you have some pictures drawn on your mind how we might take advantage of all the data structures of this series of data structure that we have learned? Stacks or queue? Can we use stacks or queues to implement it? So there are 3 methods. The first method is, let's check its correctness. The first method is that, okay, it's trying to declare a priority queue of type, and called PRIQ. We knew that, and we called PQ.remove. Then we just directly assign this new declared PRIQ equals to PQ. See, This is the problem because the old priority queue is a min heap. So if we call pq.remove, it will only remove its minima item, not the maximum item. So if we assign PRIQ reference directly to PQ, the older reference after removal, the maximum element is still left inside of that. So PRIQ is not the correct priority that we want. Instead of that, what can we do? Let's check. Can we do, the second choice trying to resort to using stack. And the third choice is trying to resort by using queue. What would be the best one? Let's see. Okay, the plan 2 start with a stack of type called S, initialized with this stack, and we use a while loop to check whether that PQ is if the PQ is not empty, then we just push everything by the removal of this PQ. Are we done? Actually, no. Let's see the last page. Then we pop. After we push everything, after we call the removal of this PQ min heap, then the last step we call s.pop. Now we created another new priority queue called PRIQ, initialize it, and as long as S is not empty, we just let priority queue to add everything that has been popped out from S. Is there any problem for that? First, we know that every time PQ remove it will gradually starting from its minimal item. First, it's smallest item first, and so on. So the last one that has been removed by we calling PQ.remove will be inserted and pushed to the top of this stack S. So that makes sense. After we finish the while loop, we let S call.pop because we don't need this element, which apparently will be the maximum element of original heap, main heap. Okay, after we do that, then we need another priority queue to store it. So we just gradually add everything that has been popped from that. So the choice 2, the plan 2 is in a correct implementation because we can guarantee that the maximum item has been removed from that. Okay, if that's true, then among those choices, since we know that the choice 1 is incorrect, so we don't have to consider A, and also we don't have to consider D, we don't have to consider E. And right now, since we have already checked that the plan 2 is correct, so we can just select B. Okay, right now we save some time for checking choice C, but just in case, let's check whether choice C is incorrect. Why is that? Okay, instead of using stack, you're trying to use a queue, and you see actually the plan 2 and plan 3 are very similar, except the first one it used queue to do the removal. So every time if the original min heap is not empty, we just let queue to add everything. And later on, the last step we call queue.remove. But to be sure that you know that originally PQ is the min heap. So if we call queue.remove for the first time, actually it will remove the first element that has been removed from the original min heap. That means it will remove the minimal element of the original min heap. So it's incorrect to call queue.remove. So no matter how we created the following priority queue called PRIQ and trying to insert everything that has been removed from the queue, the maximum element of the original PQ was still there, so which means that it's incorrect. Now, do you get what we were discussing so far? And you must be very familiar with the transition and also the usage of the queue and also the stack. Yeah, just remember this general rule like the queue is first in, first out, and the stack is first in, last out, last in, and first out. Then you will grasp the concept, and also we've already introduced you some tips for eliminating the choices as quickly as possible, and hopefully this video will help you to score faster and score higher in AP Computer Science. Okay, see you next time. Bye.